Today I'm going to be doing a teardown of my Pioneer DDJ-400 DJ Controller. When I bought this and did the video, I mentioned I was going to do a teardown and then totally forgot, and a couple of people commented asking where the teardown was, so I thought, well, I may as well do it. So, we'll do a teardown of this, and it could be quite an interesting device to take a look at inside. Obviously it's a lot of buttons which are fairly basic, but there's a lot of like knobs and faders that are probably all analog controls that are then going through some sort of A to D converter. So that could be quite interesting to look at. Additionally, these jog wheels, they're capacitive touch, so if you touch the top of them, they detect that and it performs a scratch effect, versus touching the side and that performs a pitch bend. So there's obviously a capacitive sensing mechanism that works on this top surface here. And it'll also just be quite interesting just to see how these work, how do these detect rotation, because they are pretty precise. This could also be quite good for people who have bought one of these that's faulty and they need to fix it. Because with this sort of gear, you are bashing it around quite heavily, you're hitting buttons quite hard and stuff like that. And buttons fail, faders can break or wear out and stuff like that. This isn't a particularly serviceable model like it is their entry-level model, but it would be quite good just to have a video just showing how you can take this sort of thing apart. So I'll go into that detail as well. So it's fairly easy to take apart, there's just a lot of screws on the bottom to take out. But the first thing we need to do is remove all the knobs and stuff from the top, because these are all attached to the main circuit boards, so you can't remove the circuit boards with all these still attached. So now the first things we're going to take off are these caps on these faders, so the 2-channel faders and then the cross fader. These have a locking mechanism, so unlike all the other caps that you can just pull off vertically, these contain a locking mechanism, so if you pull them up vertically, you'll actually snap the locking mechanism and have to replace the cap because you won't be able to get it to stay back on again. So it's quite hard to see, but what you'll find with these is this white piece is actually a separate part, and that's like a locking cap that slots into the black piece and locks it on. So to remove this, you just need like something quite thin, so I'm just using a pair of tweezers, but a thin screwdriver or anything would work. And just slotting that in the side there, and just push straight up. It's a little bit fiddly to do, try it from the back. But if you just slot it in the middle, and then push up like that, that causes this little white piece to ping out, and then you can lift the fader cap off. And then to put it back on again, you just need to sort of slip it back on, take this locking piece, it only goes in the right way round, and then you slot it back down again, and then push it down. So that's how you need to take these faders off. Once this piece is off, there's this little white plastic piece in here, and that'll just unclip from the vertical metal bit, because that's then going to be too thick to fit through the hole, so you need to take that off as well. And obviously be very careful with those little bits, because they are quite fragile, thin plastic. So you should do the same to this one as well, and then also do the same to the other one. Take that out, take it off, and then remove the little white piece. Like that. So I'll now just do the other one, and then we'll take a look at the rest of it. So that's these 3 faders now removed. So now those are removed, the rest is very easy to take off. With all of these controls, you just need to pull vertically upwards on them, and they pop off. However, I found that when this was new, I've taken a few of them off already. Once you take them off, they're quite easy to get on and off manually. But when this was new, a lot of them were really, really stiff to pull off. And the risk with that is when you're pulling it up, what you'll end up doing is either having to brace yourself against the machine, and you'll pull it sideways and bend the potentiometer inside and potentially snap it. And then you'll sort of try and get really tight and you won't be able to get it off at all. So you'll end up like wedging a screwdriver or something underneath here to ping it off, and then you'll scratch the surface. So what I found worked absolutely brilliantly for this is this, which is a key puller designed for mechanical keyboards. So the idea is, this is from Philco, who make keyboards. They make my keyboards, which is why I bought it. And what you do is you spread this out, you slip it over a keyboard keycap, and you pull up and it pulls the keycap off. And if you just look for like key puller on Amazon or on eBay, you'll find these are pretty cheap. And all you now need to do with this is just slot it over the knob like that, and then pull straight up, and it'll pop off. And it just means that even though you still need to apply quite a lot of pressure, you can easily apply the pressure directly upwards against the stick, so you're not bending it sideways, which is how you would damage it. So you just go through and do the same to every single knob on this device. The only one you won't get the key puller into is the track selection rotary encoder, so you do just have to kind of pull that one up very carefully, but that one doesn't stay on too tightly, which is quite good. The rest of these do stay on quite tightly. The same goes for these tempo faders. While these look like the other ones, these don't have a locking mechanism, so these can just be pulled straight up. It's only the crossfader and channel faders that actually have the locking mechanism, so those just pull off as well. So, let's just go through, take the rest of these off. I'll come back when I've done it. There we go, so that's everything now removed. So we now flip it over and take the screws out. So, just flip it upside down. And you'll see there's a lot of screws all over the base here. and we just need to take all of these out. These are Phillips 2 screws, so just take these all out, and I'll come back when that's done. There's no point showing all the boring process on video. So there you go, that's all those screws removed. And the good news is they're all the same length, so you don't need to worry about trying to match up the right screws to the right holes, they're all the same. So we can take the bottom off. So this should just lift up. I just need to tip it over just to pop it off. There we go. And then that bottom comes off. So lift it up like that. And that's the inside. That's quite a few more boards than I thought there would be in there. Well, it's going to be quite a lot of work to take this apart. I have let myself into more than I bargained for. But what we can see here is you've got a few different boards. So you've got this board here has the right deck and then the mixer section on it. Then this board here has the left deck, which is quite interesting that they've obviously made these two separate boards, but the decks themselves aren't two separate boards. There's this like is a deck and a mixer board, and this is just a deck. All I can think with this is purely just due to the size of the PCB. It's cheaper to make these two separate boards than to make a single board this size. But yeah, that's what you got there. That's those two boards. You've then got this board here, which is the headphone interface. And then this here is the crossfader, which is a separate replaceable part because crossfaders do tend to wear out if you're using them really heavily. Apart from that, there's a few more boards. This one up here handles, I think, some of the buttons on the top for like looping. Then what you've got here is this is the main interface board. So what this does is this connects the computer over USB. Should have probably shown this earlier. But it connects the computer over USB here. That'll carry all the MIDI signals from all the controls. It also has a 4-channel audio interface, so it has 2 channels in the back for the master output, then a stereo headphone output on the front, which are independent of each other. So this board here will also probably contain that audio interface. And then there's a microphone input here. I can't remember if this captures to a computer or not, like if it actually feeds into the computer as though there's a USB audio interface. I think it does. I don't think it just outputs the speakers. I need to double check that though. But yeah, what we can now do is start taking more of this off. So I think the first thing we need to do is take out this interface board here. So we'll take this out and take a look at it. So again, it's held with 4 screws around the side. Again, these are Phillips 2s. So just take these out. Just that one there. And then it'll be interesting to see what they're using in this. Are they using off-the-shelf chips? Are they using custom Pioneer silicon? You know, be interesting to see what they're doing. You know, what sort of audio interface is it? Is it a off-the-shelf USB sound card interface, or is it some custom Pioneer thing they've built? Could be quite cool. So take those screws out there. These ones down here are separate. They're just linking the 2 PCBs. So that should now have, yep, that's released. So we should just be able to pull this out carefully, lifting up slightly so it uncatches from the back. Snagging on something. There we go. And that's now out. Now what we'll need to do here is all these ribbon cables are connected in, so we'll need to carefully remove these so you can see them there. We'll just need to lift each of these up very carefully without bending them too much, because these are the sort of cheaper type of ribbon cables. They're not super robust, so you don't want to break these. They are actually replaceable. You can get obviously the right number of pins and the right pin pitch and replace them, but you don't want to have to do that. Now this one here I'm also going to pull out. However, this one here, that is soldered, I think. Yeah, that is soldered on, so don't go pulling that one out. Pull all these thin flat flex ones out. This one's solid, don't pull that out. That one's soldered and goes down onto the microphone board, or yeah, no, sorry, the headphone board. So what we'll need to do is we'll need to take this headphone board out separately. And that's important to bear in mind, because if you're trying to pull that to pull it out, you'd actually essentially rip the cable off the board. So take these 4 screws out and that'll remove this board. I presume there's a connector on this board then, because surely you wouldn't have 2 boards in the factory just sitting soldered together. I suppose you maybe might, that's interesting. Yep, pull these 3 screws out, or 4 screws out. Again, all those screws look the same length, so that makes it a lot easier to put together. Ah, here, and there you go. And now that is a removable connector, I think. Is it? Somehow. Ah, it's well, it's like one of those ones when you pop the sides up. Yeah, so you pop the sides up, then that pulls out. Somehow. Do you? It is a removable connector, but it's not coming apart very well. Oh, there you go. So that pulls out at an angle. So that comes out, and that we just push back in there. That's not my favourite design, having like a cable permanently soldered to this board and then a really janky connector on this board with these like just bare wires that almost push in. But yeah, that's not that nice. What I'll do is I'll just quickly put that back in there just to protect it, because I can just deal with these two boards being stuck together. So it's a bit of an odd design there. But what we'll do is let's take a look at this board. This is probably actually the most interesting board in the whole thing, so the rest of the video is probably going to be a lot more boring, but yeah, we'll go through and see what this has. Well, actually, it doesn't look like it's that complicated. What I'm also going to do very quickly is I'm going to take this board out of this metal shielding, just in case there's anything on the underside, because it doesn't look like there's too much on the top here. So we'll need to take this little locking nut off this microphone connector, remove the screw that's above each of these jacks, and then just remove all the screws on the PCB to take it out. So that's really, I'll just get like a spanner or something for that, or some pliers, but we just do these ones quickly. Just because I can't see an audio interface on this, so I'm guessing it must be on the underside of the board. Unless they somehow integrated all of that into a single chip, which I'd be impressed if they have done, but can't see why you would. So, see what's on the bottom here. Now, if you're servicing this, you probably wouldn't go into this much detail. Like, if there's a problem with this board that's beyond like a bad capacitor or something, you're probably not going to dig into it much more. You'd probably just replace the whole part if you could find it, but may as well take it apart and just see how it works, because that's what I'm basically doing on this video and this channel, basically. There we go. So that's all those removed. The only thing I need to do now is just get a set of pliers to take that locking nut off there. Then we'll take a look at the board. Okay, so that's that little nut removed. So we can now hopefully just pull this whole board out. So yeah, that just lifts out, and that comes out this metal case, so that can go away. And then we can see if there's anything interesting on the underside. And there's a bit on the underside. So what I'll do is I'll go away off camera, try and work out what I can see here, just see if there's anything particularly interesting to talk about, and then I'll come back and talk about it. Okay, so I've had a dig around this board and found out a bit about how it works. So first thing is this other board here, the headphones. There's basically nothing on it. There's just a headphone jack and a pair of capacitors. So it's purely just an interface board. There's a couple of little bits on the bottom, but no real logic here. It's just an interface board. But this board here actually has quite a lot of interesting stuff on it. So the first thing I noticed here is you've got these two model numbers, the DWX-4132 and the DWX-4152. Now that points to two different models of Pioneer controller. I can't remember which way around it is, but one of these is the DDJ-400. The other one is the DDJ-SB3, which is the Serato version. Now the SB3 is quite a different layout to the DDJ-400. The DDJ-400 was quite a big design overhaul, whereas the SB3 was just a sort of evolution on the SB2. But it's interesting to see they do actually use the exact same control PCB, and probably just have different firmware flashed on them. I suppose they might change a couple of the components on here and just have the same PCB like layout itself, but I wouldn't be surprised if they do use the same PCB and just flash different firmware on it. Although it's probably worth bearing in mind, if you are having to replace this, make sure you buy the right one for your controller, because what you don't want to do is buy one for a Serato controller and try and put it in the record box controller, because you probably will have issues in the firmware. But yeah, found that quite interesting. Now there's this big main chip here that I can't really find much information on. Its model number is a 72670P144FP. And the most I can really find is this is some sort of like RISC microcontroller. I can't remember who it was made by again, Renaissance Technologies or something like that. It was some sort of RISC microcontroller. It might not even be that, it might just be custom Pioneer silicon that just happens to share a model number. But it looks like some sort of generic RISC microcontroller type thing. Apart from that, on the top, there's not really that much else. There's just a bunch of sort of capacitors and just various electronic components. So if we turn that over, you'll see the rest. There's a bit more interesting stuff on the bottom. So at first glance on the bottom, you can't really see much of real interest, just a few little surface mounted chips. Now, a lot of these chips are JRC MOSFETs, and they'll be just acting as not MOSFETs, JRC op amps. And those op amps are controlling things, are working for things like the audio interface, the audio in, the audio out, and stuff like that. However, there's these two banks of chips here that are quite interesting. So the first bank you'll see on the left here has these three identical chips, and these are VHC 4051As. And these are analog multiplexers. So what these, I'm guessing, it'll be interesting to see when we take a look at the rest of the thing, But I'm wondering how much of the stuff that's sent from the main boards up to this is just analog signals from all the faders and knobs. And what these will do is these will multiplex that so they can be connected to the microcontroller and use less pins on the microcontroller than having one pin on the microcontroller per analog control on the main device. So it'll be interesting to see if this is the only multiplexing they're doing, or if there's also multiplexers on the main boards as well, and this is like a second stage. That's what those are. And next up there's these chips here, which are actually all the audio hardware. So the middle chip here is an AKM 5358 AET, which is an analog to digital converter. So this is for the microphone input. The two on the outside are AKM 4387 ETs, and these are DACs, so those are for the main master output here, and a second one for the headphone output. And what I find quite amusing is that the DAC and the ADC is the opposite way around from the DACs. So I imagine that's just the way they're laid out, that all these chips will have the analog pins on one side or something, so flipped it around because one's a DAC and one of the, like two of them are DACs and one's a analog to digital. But yes, that's the hardware there, it's controlling the audio, which I find quite interesting because surely there's enough like off-the-shelf USB audio interface ICs they could put on that would have, 4 output channels and a single input channel. It's interesting to see they've done it with what appear to be separate, discrete DACs and ADCs hooked up to the microcontroller. But yeah, that's quite interesting. I suppose it makes it easier to interface over USB. But yeah, that's the main sort of control PCB there. So now that's all out of the way, let's take a look at the main board here. So as I mentioned before, this is divided into 2 parts. We'll take a look at the leftmost part first, because I imagine this will have most of the interesting stuff in it, given it's got both a deck and the mixer. We'll then take a quick look at this, but I imagine it's just going to be the same as this part here, just split off onto a separate board. So what we'll do is take these 2 links out here. These just seem to literally just link the 2 boards together. A lot of the work in these is to make it rigid and sturdy, and not flex and bend around, because these things do need to take a beating and be quite solid when you press buttons. You don't want to have a situation where you're pressing a button and the board flexes and then the button doesn't register. Because a lot of time if you're using something like this, you can't afford for a button to not register, because it'll totally throw the mix off. So that's what a lot of this stuff will be, is it'll be to make it quite rigid. Because even though this isn't a particularly high-end one, it is still designed to be fairly well made. Like, it is a decent Pioneer one, it's not total cheap rubbish. Let's take these 2 boards out here. Or not boards, little metal plates. Hopefully we'll put this back together again, because that would be very unfortunate if I fail to remember how this goes back together, but fairly easy. So that's those now removed. Now there's a lot of screws all over this to remove, because again, as I mentioned before, it has to be sturdy. You couldn't just put a screw in each corner, because then pressing buttons would cause the whole board to flex. So there's screws absolutely everywhere to support this. So we need to take that out. I'll do that off camera. This little board here looks interesting. As far as I'm guessing, this is probably just some sort of mechanical support, because I can't see any electrical connections to this board. So behind this there's just a few buttons for the looping, it seems to be. I think there's loop buttons behind there. So I'm guessing this board here is literally just mechanical support, and they just use PCB material because, well, it's probably quite cheap and easy to cut to size and put the right holes in it if they're doing PCBs for the rest of the thing. So let's see, is this just literally a bit of mechanical protection? Yep, that's all that is. It's literally just using a bit of PCB material just as a piece of mechanical protection for those buttons. Interesting, there's nothing over here for that, but with this side you do have that other audio interface board over. Again, this must just be purely due to the sizing of PCBs they can make, because this board's slightly taller, so they don't need that piece. Whereas this board's obviously slightly shorter, so they need that piece there. And all I can guess is it's potentially just something just due to the size of the PCBs they can make. I suppose there's always a cost, and once you go up to a certain size, you're having to get different machinery in, and it's maybe harder to have done that. Kind of weird. So this board here and this board here with the crossfader, these seem to be a similar idea to that headphone board, where they're using these horrible like flat flex cables that seem to be like permanently soldered. So I'll need to take those all out at the same time. So I've now got the fun task of removing all of those screws, and there's a lot of them. So, oh god, as you can see up there, it's number 31. So yeah, there's going to be a lot of screws to take out. So I'll do that off camera and come back. So I've now gone round and removed the obscene number of screws on this, so we can now lift the board out. Now you could probably turn it upside down and cause the board to drop out, but I don't cause all the buttons and inlays for all the buttons to fall out. So I'll just carefully lift it all up, including those two boards that are fixed on, and move it out of the way. So now under here you can see obviously the main mechanism. Most of these are just little insets on the buttons, so these are just little plastic pieces that just sit in the holes and push the buttons on the PCB. Some of those are clear for LEDs, some of those are black. Here would be the rubber pad for the performance pads. That's obviously come out with the other piece. Take a look at that later. And then looking at this jog wheel here, I can actually see it must be optical based, because what I can see right up in there, I'm not sure how well it comes across the camera yet, it seems to come out, is there's this little wheel, and that's got little teeth on it. So I'd guess if we look at the main PCB, there'll be some sort of photocell and like LED combination that'll be being used to detect the rotation of that. And then I'm guessing the capacitive touch is maybe somehow through this little tab here is potentially connected through to the top surface. But we'll take a look at that later. But yeah, that's the inside there. And then there's those little foam pads there, which I think are just designed to keep dust out the faders. Obviously if dust does get in, you might need to come in and clean it out, but yeah, that's just like just a little thing to help. And those are the light sort of, those are the like VU meters, and it's quite cool. It's got little like walls across it to stop light bleeding between the different parts. But yeah, that comes out, and then that's obviously the outside of there. I won't turn it upside down because all these little buttons are going to totally fall out. And it's worth mentioning to bear in mind to be very careful with these little plastic bits if you take them out that have the buttons on them, because it's quite easy to snap them at times on devices like this. And when you snap them, you've basically broken that button. So now here we have the main PCB. So let's flip this over and see what we can get. And as you can see, it's you've got a separate crossfader here and a separate board up here, which just really provides the browse and track select buttons. But if we flip this over, there we go. Now that has fallen off. So that's the performance pad. So you can see it's just a big rubber sheet with little buttons on the bottom that will just push through onto these tactile buttons on here. Nothing particularly fancy, but yeah, that provides the performance pads. So yeah, there's actually quite a lot going on here. It's also interesting seeing this is a single-sided board. Obviously to save cost, it's a single-sided board and there's just a lot of little links across. But I suppose that's quite easy to do on something like this because it's not got that much on it. It's not densely populated. It's a lot of individual controls and LEDs that are all spaced out across the board. So there's probably no real reason to do a double-sided or, any more than a single-sided board because there's plenty of space to put all these little links in. But yeah, that's what we've got. So what I'll do is I'll take a quick look into this a bit closer, see if there's anything interesting going on. It does look just very analog sort of stuff. But yeah, I'll pop my head down, take a little look at this, and then come back. Okay, so I've now dug into this board a bit more, and as I suspected, there's not really much active circuitry on this at all. All this board really has on it is just buttons, LEDs, potentiometers, and sliders that are also essentially potentiometers. So over here is the mixer section, which just has a lot of different pots for all the EQs and gains and all that sort of stuff. You then got the 2-channel faders there, and then a crossfader down here on a separate board that can be unplugged, so you could replace this if you needed to. Then this board up the top here is a completely separate board with a rotary encoder for track selection. And again, I suspect this is just due to PCB sizing that they've had to put that on a separate board. It does all feel very, very nice quality though. And what's quite cool is seeing how well labelled everything is. So you can see down here, for example, all the knobs are labelled with what they are. So that's FX level, that's FX on, everything's labelled. And I also noticed that up here, for example, certain potentiometers are labelled with click and non-click. So that's non-click there. And you'll notice this one here says center click. And that's the sort of notch you get to. So this one's master volume. So when you turn that, it's totally smooth all the way around. But these are all the EQs. And when you turn these, when you get to the middle, they sort of have that little bit where they sort of stop in the middle. So they've actually even labelled that on the PCB. So potentially if these are being assembled or you're repairing it, you can quite easily see what types you're to put into each of these areas. Additionally, on the back, which is quite nice, because it's a single-sided board, there's a lot of links across on the top that link the multiple tracks together. But most of these are actually labelled. Try to find an example. You can see here, for example, there's jog dial 20, jog dial 21 that come out down here. And these then bridge across, and they've actually labelled all these bridges. Ground F, ground LED. They label all the, they're marking all the jumpers that go across the top on the bottom of the board, which makes it really easy to trace the circuits out, which is quite cool. But yeah, there's not really much on here in terms of active circuitry. Then down here you've got this switch here that slides along, and that's for the deck you want to put the effects unit on. And again, that's just like a little switch with a little cap on it that sits on it there. Now the one bit I did find quite interesting though is how it does the jog wheel. So what you'll see over here is, as I suspected, there's a pair of light gates. So these are spaced a sort of certain distance apart. I can't quite wrap my head around how this works. If someone can explain it in a way that I'll be able to understand, that'd be really helpful. But obviously those teeth on that wheel I showed earlier are going to move through this when that wheel's turned. And it must just be due to the spacing of those teeth and the spacing of these light gates. It can obviously determine the rotation by how quickly the teeth flash past the gates. But there must just be something just due to the spacing on these that it can somehow determine the direction based on probably just based on the timing between the flashes in each of these. So that'll be detecting the timing. As for the capacitive sensing, you can see there's this little tab here. And this little tab here connects onto the jog wheel via this connection here. And that's electrically connected through to the top of the jog wheel on the surface you touch. Now what that means is that when you touch the jog wheel, that connects you through to this, and it can do capacitive sensing. And this is the only active bit circuitry I can see on this board, is this little PIC microcontroller, which is a PIC 10F206, which is a very small PIC microcontroller. And if you look on the bottom, we can see that's the bottom of there, it's connected onto the pad here, through a few passive components, and then the output of this connects all the way up here, and it connects this jog touch 2, and then that traces all the way back, and it traces back to this main connector that goes up to the main board. You'll see jog touch 2 is labelled in one of these. There it is there. So that's one of the pins on this connector. Pin 2 is jog touch 2, which connects to this microcontroller. So what I suspect they're doing here is they're just using this little PIC microcontroller to detect the capacitive sensing. So it must just be because it's probably just measuring a voltage level or some sort of voltage level. And they're doing that on the microcontroller here, and then this will send out a very simple digital pulse, for example, as to whether it's being touched or not. And offloading that to here probably makes a lot of sense, because it means they can just send a digital signal up to the main board. And something like a capacitive sensing touch surface is probably very interference prone, so sending the signal from that all the way through traces on the board over cables up to the main board are going to cause interference issues. So instead they offload that to this little chip here that sits right next to the jog wheel, and that can output a digital signal that's a lot easier to transport. So that was definitely pretty interesting to take apart, and it does look pretty serviceable. It's not particularly designed for it, but yep, if you broke one of these knobs off, one of these faders wears out, one of the buttons stops working, something like that, it'd be very easy to take this apart and just replace it, because it's all through-hole components, so you just be able to desolder all the buttons, desolder all the knobs, or just get them with contact cleaner. So yeah, it does look quite serviceable, which is nice, and it seems pretty nicely made. I also noticed amusingly over here, similar to the top board, it shows the model number of the DDJ-400, the DWX-4154, but it's also got this other bit here that's blanked out, almost as though they could like write on or like stick a sticker on with a different model number. So I'm wondering if this is made for like future revisions of this device where they might use the same boards but in a different model, for example, a new Serato version they might launch, and then they use the same boards for it. And then there's this little link here, this little J5, J4 next to these model numbers. So I wonder if these are a way of selecting what model this board's used for. Because that's all I can see, it's just sitting next to those. But in fact, those links don't actually appear to be electrically connected to anything. They just literally, because this is a single-sided board, those literally just seem to sit there. So are they purely doing that? Is that link purely like a little tick mark, just literally an indicator on the board? It must be, because there's no electrical connection on that link. So they're actually using like a little solder link, or a little wire link to indicate which of these models it is. Kind of bizarre. But yeah, it's quite interesting, obviously, making this board available so they could use it in other models in the future. Because realistically, if they wanted to release a Serato version of this controller, as long as they wanted to have the same layout of buttons, they could just use these boards and just put different firmware on it, which is what they're obviously doing with that top board. So yeah, that's the main PCB that has one of the decks and the mixer. What I'll now very quickly do is I'll pop out this other board. I'll take this out off camera and take a look. I suspect it's going to be just identical to the other one without the mixer section, but I'll do it anyway and then I'll come back. Okay, so I've now removed all those screws, and if I take this out, I'd be willing to bet it's going to be identical. So yeah, we've got the same layout here. There's your fader, There's the rubber pads for the performance pads. It's an exact copy of the other one. So we'll get out of the way. There's the board, looks very similar. Flip it over. As we can see, it is practically identical. It's just not got the mixer section. So you've got the exact same thing. You've got, there's your tempo fader, all the buttons for the performance pads. You've just got the same pick microcontroller doing the capacitive sensing, same light gates. The only difference you've got this additional section here, which is for the headphone adjustment. So one of these is the headphone, is the Q versus master mix, and the other one's just headphone level. So you've got these two additional pots here, but that's it. And once again, we've got that bizarre jumper next to the model number that, yeah, it still isn't electrically linked to anything. Never seen that before. But yeah, that's the other board. And as you can see on these boards, it's the exact same with the other one. There's just a couple more cables for the mixer section. All of the buttons and controls and everything like that are just essentially one-to-one mapped onto this ribbon cable. So you can see all the buttons there are all labelled, grid 3, grid 4. They're all just labelled onto individual connections on this main cable, including the analog ones, it seems. So it's sending all the analog signals up to the main board, and then that's doing all the A to D conversion for the microcontroller to read the settings and all the potentiometers and stuff like that. It's quite interesting, but I suppose it makes sense. Get it all up there, because the only analog stuff this particular board has is these two pots and that fader. Most of the analog stuff's on the mixer, but then it just does the same, it just sends up to the main board. So yeah, it's quite an interesting design. You could definitely hack it if you wanted to, but I wouldn't bother with something like this. But you could obviously, it does make it very repairable and quite easy to debug. Because when I bought this, but I've been looking on eBay at sort of similar controllers, and you'll quite often see ones that say, oh, it works fine, but this button doesn't work, or the channel fader for this channel doesn't work. And while that could potentially be an issue with the A to D converter, chances are, if it's just a simple issue with a dodgy potentiometer or a dodgy trace on the board, it actually looks quite easy to fix. You could probably quite easily trace this out with a multimeter, probe different connections and stuff like that, because it's all so well labelled, and it's just a simple single-sided board. So this does look quite serviceable, which is quite nice. So there we go. It's now time for me to put this back together. And I've now got to put in this many screws to connect these boards into the case. So that is not going to be fun to do. And then there's even more screws to actually put the case back together and to put that audio interface and USB interface board in. But yeah, going to be a lot of fun putting all these screws back in. But yeah, time to get it back together and hope it works and I've not broken it. So there we go. That's all reassembled and it all went together perfectly fine. Fairly easy to put together. A lot of screws to put in, like that number of screws is ridiculous. But once you get them all in, just shove the bottom back on, turn it back up, the right way up, and just clip it all back together. And even putting these fader locks back together was just a case of reversing the process that I did to take them apart. So yeah, fairly easy to take apart. And it was a pretty interesting device to take apart. I'm glad I did it, just purely just to learn how it works. So it's quite interesting seeing how they've got all the stuff on all these boards just analog apart from a little microcontroller that they're outsourcing the capacitive sensing to. And then there's that main board that handles everything. And it's also just interesting seeing how serviceable it looks and how, it's all quite well labelled. You can see how the circuit boards are all laid out. There's no sort of obscurity, there's no details hidden away. So yeah, it's definitely quite a nice little device. Definitely very well made. And yeah, fun little thing to take apart. So there you go. Thank you very much for watching. If you're interested in buying one of these, there's links in the video description.